Hey guys, this is CalcMedic, Unit 5, the multiple choice questions. I thought I'd make a video going over these 10 multiple choice questions. So let's get started. So, we have our first question where we're given f of x, select values of f of x. So we don't know, we just know that f of x goes through, these points. We don't necessarily know how it goes through those points, but we know that that must stop through these 5 points. So first statement, the maximum value of f on 1, 5 is 18. Okay, well, of the listed values, we do see that 18 is the highest, right? Which would be, let's just say our value's up here. But what could happen is it could go like this and then come back down. So we don't know that this maximum value is 18. So this is not, we don't know that this is true. F prime of x must be less than 0 for all of from 2 to 5. So x is 2 to 5. Well, it does go down at each step from 2 to 5. However, it could go down and then come up and then come down again. So f prime is not, it would be positive here. So we don't know that f prime is always negative from 2 to 5. The general trend is downwards, but it could go up and then come back down again. So this is also, we don't know that this is true. 3, there exists C for which to C to 5, there exists C where C is between 1 and 5 such that f prime of C is equal to 0. So what it's trying to say is this is a mean value theorem problem. Well, actually, Rawls. This is Rawls' theorem, but it's also a version of mean value theorem. So we have our endpoints here, which is at x equals 1, it's 10, and x equals 5, it's 10. So if I'm to draw this on a graph, let me draw a better graph here. At 1, 2, 3, 4, 5. So let's call this 10. And then I'll just make some points. And this is also 10 right here. The average slope of this graph is 0 on the interval. The interval is continuous and differentiable, so mean value theorem or Rawls' theorem does apply. So that means no matter what path we take, so if we took a path through these points, well, at some point, if we'll have to have a slope of 0, right? So let's say our function increases like this one does. Well, the function must end up coming back down, right? And so when it starts coming back down, well, it hits a slope of 0 at this point. Let's say the function decreases at the start, right? Well, in order to get back up to this point, it will eventually have to have a slope of 0 to get back to this point, right? What the slope of 0 would be here. It doesn't matter what the function does. Increases, decreases, it could just, it will eventually have to correct itself to come back down. And so the function would be 0 here. So that's basically what mean value theorem says. Is that if you have an interval where it's continuous and differentiable across the interval, across the whole interval, then you can get the average slope of that interval, and at some point there must be an x value, in this case they're calling it C, to where it matches the average slope of the interval, which are the average slope of our interval is 0 because it starts at 10 and ends at 10. So the answer is C, which is 3 only. This is just explaining that the average slope of the interval is equal to 0 because it starts at 10, ends at 10. Okay, here we go. On y equals f of x in a closed interval, negative 2, 6, how many points of inflection does this graph have on the interval? Okay, points of inflection is where a graph changes concavity. Well, this is what we're going to use to solve this problem here. So we start here. We have this nice little curve here, and then now we reach. How do I want to do this? We start with this curve here, and then it becomes this curve here, and then it becomes this curve here. So what we end up having is we have a point here where it changes concavity between, and then we have a point here where it changes concavity. And we can't determine that it changes concavity at each of these endpoints. And to briefly go over what concavity means, if it's concave up, that means that a graph is above its tangent line. So everything is above the tangent line here. This graph is above the tangent line. Only at this point where it changes concavity, it becomes concave down. This graph is below the tangent line. This graph's below the tangent line. This graph is completely below the tangent line. So it changes concavity. And same thing down here, it changes back to a concave up. So it's always above the tangent line. So there's 2 points in concavity, and we can't determine that it changes at either of these points here. So we get these 2 purple points here, and that's the answer. Yep. Graph of f changes concavity. Okay. So, a couple ways to do this one. It's saying that we have one graph displays the function f of x, another displays the derivative of the function f of x, and another displays a double derivative. Okay? One thing is we have to identify which graph is which. One thing to do is we can identify what this graph is. I mean, this clearly looks like an x cubed. This is just a y equals x function, an mx plus b. But it's of order x, right? So I only really care that it's of order x. And this one is clearly an x squared function. So if we were to just do it visually, well, x cubed is f of x. X squared is f prime of x, right? Because when you take the derivative of x cubed, we get an x squared function. And then when you take the derivative of x squared, you get an x function to the first power. Okay. Another way to potentially do this is that you could take a look. This is clearly the graph that's linear, and the other graphs have curves, and so you could recognize that this linear graph must be the one that is the double derivative, and then this one only has one curve, and this one has two. You could recognize, hey, at x equals, maybe like negative 0.8, there's a slope of 0. So if you could take a look, well, at here, there's a local minimum. So this must be the derivative of this one. And same here, you could say, oh, there's zeros at negative 2 and positive 0.5. Well, you get a local min at 0.5 and a local max at negative 2. So this must be the derivative of this one. So because of this, you get 1 is equal to f of x, 3 is equal to f prime of x, and 2 is equal to f double prime of x, which is answer E. Okay, this one's a bit of a tricky one. So this is a graph of f double prime. And basically, it's saying all of these 5 points are x-intercepts of f prime. So if I'm to draw a graph of f prime, I would draw a graph f prime. Well, there must be a point on A, x equals A, on x equals B, on x equals C, on x equals D, and on x equals E. So this is a graph of f prime, right? This is the integral of this double prime here, right? It's where this is A right here, B, because this is what the problem gives us. The graph of f prime has x-intercepts at each of these points. For which of these 5 points does f have a relative minimum? Okay, well, we know that if f prime has zeros at these 5 points, okay, well, that means that they must be critical points, right? So they could be a minimum, maximum. They might be neither, right? They might be just a critical point. But what we can do is f double prime is going to describe the slope of f prime, right? So on both sides of A, for instance, on both sides of A, there's a negative slope on both sides of A. So this must be negative and negative. It must go like this. Same with both sides of B. On both sides of B, it's negative and negative. C, because this is below the x-axis, the slope of C, also, both sides of C is negative and negative. Both sides of D, the slopes are, this whole part of the graph is negative. And so all the slopes under here are negative here. But for part E, well, it's above the x-axis. So on both sides of E is positive. It's a positive slope. So if we are to do this test for this first derivative here, which of these is a relative minimum? Well, relative minimum, if you have a relative minimum, the slope decreases before a relative minimum and then increases after. So if I were to look at each of these points, well, now we're looking at whether the slopes are positive or negative on this graph. Well, this starts out positive and turns negative. This starts out positive, turns negative, right? And we want something that starts off negative and turns positive. This also starts out positive because above the x-axis, turns negative. Starts out positive, turns negative. But E starts out negative because it's below the x-axis and goes positive. So we know that E it must be a relative minimum. Also, there is another way to do it, in which case, if we know that f prime of x is equal to 0, and f double prime of x is greater than 0, well, we know that x must be a minimum, or local min, relative min. I believe it's the second law of, actually, I think it says down below. So we already got this E, the second derivative test, that's what it is. Okay, I wanted to explain more so that you had another way, because I never liked trying to memorize these tests. Okay. Ooh, I actually got this wrong at first. And you'll see why I got it wrong. This is the only one I did get wrong. Okay, we want the product of x, y. So, well, we have y is equal to 4x plus 6. So xy is just going to be multiplying everything by x. So x times 4x plus 6. Okay, well, from this point, we want to find the minimum value. So if we want to find a minimum, we can take the derivative. Let me finish this, though. 4x squared plus 6x. From here, we can take the derivative of this. Derivative of 4x squared, okay, well, that's going to be 8x. Derivative of 6x is going to be just 6. These are just power rule of derivatives here. And so we want to find, if this is the derivative, right, this is, we'll call this just f prime here. How do I want to do this? This is f prime here. So we want to find where this is equal to 0 to find any critical points. So 8x plus 6 must equal 0. So we get 8x equals negative 6. And then x is equal to negative 6 over 8. When we divide the 8 over, which is equal to negative 3 over 4. And of course, me not reading, I put, okay, the answer must be negative 3 over 4. But it's asking for the product xy. Oh, and also, in order for something to be a minimum, remember, it has to, the slope has to be decreasing, the slope has to be negative, going towards the minimum, and then positive going away from it. And we can see that since it's just a straight line, this is negative and then positive. So we do have a minimum with x equals negative 3/4. But we want the product xy. So we have to plug it back into our xy function, right? So xy is equal to 4x squared plus 6x. So when we plug in for negative 3/4 for x, we get this plus 6 times negative 3/4. And at this point, just solving for it, so you get 4 times 9 over 16 minus 18 over 4. And here we get the 4 cancels out the 16 to get just a 4 underneath. You get 9 over 4 minus 18 over 4. And so you get negative 9 over 4. And so that's why we get A here. So halfway done. Okay. So we have the graph of f prime here. So it is the derivative of f. Which of the following open integrals is the graph of f concave down? Okay, well that means we want for concavity we want f of double prime. And f of double prime is just the slopes of f prime. So we need to just take a look where slopes of f prime are negative and positive. So from here to here, the graph is decreasing. So the slope's negative here. So that means on the graph of f double prime, the derivative of this is going to be below the x-axis. Now slope is going to be, the slope is increasing here up to here, and the slope decreases, or the slope is negative here. Yeah, I should be saying the slope is negative from negative, so the slope's negative from -2 to 0. And it's also negative from 3 to 4. Okay, and so that is where the graph is going to be concave down. And so A is the only, A includes -2, 0, and so only answer to do so. None of the answers include this one, so the most correct answer is A. Okay. Optimization problem. Apologize for my phone. Just letting you know, it's that your teacher is the one texting me, interrupting this beautiful video. Okay, so we have the cost of materials represented by number of units. We have the cost of labor represented by number of units. The total cost is the sum of the materials and the labor, the cost of materials and the cost of labor. Okay, that seems easy enough. So let's call total just T of X. Well, the total cost is the sum of the cost of materials, which is C of X, and the cost of labor, which is L of X. And then we can just plug those in. So T of X is equal to, C of X is equal to 100 over X. L of X is equal to 0.5X, 0.5X. Okay, how many units should be produced in order to minimize total cost? Well, okay, we need to find a minimum. So in order to find a minimum for graph, we can take the derivative. So we take the derivative here, t prime of x. This is just power rule stuff. 100 over x is just 100 over x is the same thing as 100 times x to the negative 1. So basically then when we take the power rule, we get negative, sorry about that, negative 100 over x squared, because x squared is x to the negative 2. And derivative of 0.5x is just 0.5, 0.5. Okay, well, we want to find out, to find a minimum, we need to find critical points, right? So we want to find out where this is 0. So we set this equal to 0, negative 100 x squared plus 0.5. Okay, and so we can subtract 0.5 over, multiply x squared over, equals negative 100. And then we can divide negative 0.5 over, we get x squared equals 200. And then we can square root both sides. If I could draw a square root. I'm sorry, I'm just silencing my phone. And when you do square root, well, this just becomes x. This becomes square root of 2 times square root of 100. And the square root of 100 is just 10. So we get x equals 10 square root of 2. Well, you might think, wait, we don't have anything like that. First, it says approximately right here. So square root of 2 is about, and they give you your calculator, so you can find this out. Square root of 2 is about 1.4. So 1.4 times 10 is about 14. It's about 14. Because square root of 2 is like something like 1.41 or something along those lines. But putting into the calculator, it's about 14. We have to figure out, wait a second, in order for it to be a minimum, it has to start out negative and become positive. So when we can test a number, we can test t prime of 10 and see if it's negative or positive. Actually, it's better to test a point closer. If you test t prime of 13, we get negative 100 over 13 squared, which is 169, plus 0.5. Well, you can put this into a calculator, and this is greater, or this is less than negative 0.5, so this turns out to be t prime of 13 is less than 0. Okay, which is a good start. Then we can plug in t prime of 15. I'll do t prime of 15 here. Which is negative 100, and 15 squared down below is 225. And again, plus 0.5. Well, you can see from here, 100 over 225 is greater than negative 1/2, so t prime of 15 is greater than 0. So we know that t starts out below 0, or the slope starts out below 0 and then it goes above 0. So we know that it must be like this in the original graph, and then this must be the minimum. So x around when x is about 14, it must be a minimum. Okay. So f prime of x is sine x squared on which of the following intervals 0 to pi is f increasing? Okay. Well, if we plug in 0 and pi into sine x squared into we have to okay. So if we plug in 0 to pi, 0 and pi to sine x squared, well, f prime of 0 is sine of 0 squared, which is just sine of 0. Which in this case is just 0, but I'm more concerned with what's inside here. If we get f prime of pi, we get sine of pi squared. So the reason why I'm doing this on a normal sine graph, and since this is a calculator, you can even graph sine. I'm doing two cycles of sine here. I'll do a third one as well. So this is 0 here. At this point is 2 pi. This is a typical sine graph. This is just the graph of sine of x. So what I'm doing is I'm basically changing the problem a little bit so that we're going from 0 to pi squared. On the on sine of x. And so this is 4 pi here. And pi squared, well, pi is about 3, right? Pi is around, it's 3.14. We'll call it around 3. And so pi squared is going to be slightly more than that. So it's going to be between 9 and 10. It's going to be 9.9 or somewhere between 9 and 10. So in other words, 4 pi, 4 times 3 is 12. So we're basically going from here to around here. So on which of the following intervals is f increasing? Well, f is increasing from 0 to pi here, and because it's positive, it's negative from here to here. I'll put the positives in blue. So it's positive from here to here. It's positive from 2 pi to 3 pi. So from this point, okay, well, we know then this function is positive when we get sine of 0 to sine of pi. And sine of 2 pi to sine of 3 pi. But we have to remember that this is actually sine of x squared. So in other words, we're going to have to put x squared equals 0 for the first interval. The left of the first integral, x squared is equal to pi. For the second, for the first interval, x squared is equal to 2 pi. X squared is equal to 3 pi. So, well, so then that means the first interval is going to be 0, but x is going to be between 0 and square root of pi. And then because x squared is equal to pi, so and then the second interval is going to be square root of 2 pi x is between the square root of 2 pi and the square root of 3 pi. And when you plug those into a calculator, you get a here. Square root of pi is 1.772. Square root of 2 pi is 2.507. Square root of 3 pi is 3.070. And so that's kind of how you find this. Another way, I wanted to show you how to do it this way. Another way is you just graph the equation, sine of x squared, and this is what you get, and you can get the intervals just from the graph. But in case you're not given a calculator, this is how you do it. What I showed you is how you do it. Wherever this is positive is your answer here. So it's positive from here to here and here to here. Okay, so okay. This is calculator. So we want minimum, right? Okay, well, we have our function. Let's take the derivative of this. So f prime of x equals 4x cubed minus x. Okay, well, we want to make this equal to 0. F prime is equal to 0. 4x cubed minus x. In case you don't get a calculator, well, we can do this algebraically. You can take x out, you get 4x squared minus 1. Okay, well, so we know one of the roots is x equals 0. But we can do a bit better. We can break 4x squared minus 1. So x squared minus 1, you might remember from algebra, is x minus 1 times x plus 1. So 4x squared minus 1 is just 2x minus 1 times 2x plus 1. So from this point, we get x is equal to 0. If x equals 1/2 here, then it's also equal to 0, so that's another root. if x is equal to negative 1/2 here, this also becomes 0. So x is equal to 0, 1/2, and negative 1/2. Well, we need to find out which is the absolute minimum. So we need to, for f prime, the absolute minimum is when it starts out negative and turns positive. So we need our number line here. We get 1/2, or negative 1/2, 0, and 1/2. If you plug in f prime of, I'll test negative 1 to test here. F prime of negative 1 for 4x cubed minus x, which is what we're using. We get 4 times negative 1 to the third minus negative 1. And we get negative 4 plus 1. We get negative 3. So this is a negative over here. If you do this with f prime of negative 1, let's just do negative 0.1, make it easy on ourselves. You get 4 times negative 0.1. I should have put a 0 in front of the other one, but I guess it doesn't matter too much. Minus negative 0.1. Well, you get negative 4 over 1,000 plus 1 over 10. And so you get a positive number. So this is going to be positive. And you can test positive 0.1, and you get a negative here, and you can test 1, you'll get a positive. Just doing this to make this a bit briefer. So an absolute minimum is when it goes from negative to positive. So negative half is 1. However, it goes from positive to negative at 0. So 0 is not a minimum. And then negative to positive 1/2 is also a minimum here. And because you have your calculator, you can plug this in. You'll get some type of function like this, and you'll see that these two are the absolute minimums because the function increases on both sides at the very ends. So yeah, let me move on to the last one. There you go. Right there. Okay, last one. So it's asking for, we have f double prime is equal to sine x plus cosine x. And so does the graph of f have a point of inflection? Okay, well, point of inflection is just where this is equal to 0. Okay, so from there, and so from there we can, I'm sorry about the noise. We can subtract the cosine of x over, because sine of x plus cosine of x must equal 0. We can divide cosine of x over, and we get sine of x over cosine of x. Is equal to -1. Well, sine of x over cosine of x is just tangent of x. So in other words, we want when tangent of x is equal to -1 to get a point of inflection. Okay, so we might remember from unit circle, right? From unit circle, I didn't memorize the tangents from unit circle. I just remembered the sine and cosine. I just know that tangent sine over cosine. So if tangent's equal to -1, well, I'll start with the first quadrant where everything's positive. Where tangent's equal to 1 is at pi over 4. At pi over 4, sine and cosine are the same thing, so tangent of x is equal to 1. And so you can remember, I forget the mnemonic, but it's something like all students taste chocolate or something like that, or maybe I think it's all students take classes. A means all, so all trig functions are positive in A. S means only sine of the major 3 is positive. T means only tangent of the 3 is positive in the third quadrant. And C means cosine, only cosine of sine cosine tangent is positive in the fourth quadrant, right? We got quadrant 4, quadrant 3, quadrant 2, quadrant 1. So we want where tangent's equal to -1, not 1, right? So we know tangent's equal to 1. It's positive 1 in the first quadrant because all trig functions are positive. And we also know that tangent's equal to a positive number in the third quadrant because tangent's positive in the third quadrant. So we don't want 1 or 3. However, in 2 and 4, we know that tangent is negative. So the angle is 3 pi over 4, and the angle is 3 pi over 4 in the second quadrant and 7 pi over 4 in the fourth quadrant, because all these values are pi over 4s for when tangent's equal to 1. So from the interval and from here, tangent's equal to -1. So if you do 3 pi over 4, that is the only one, if you check in the calculator, between 0 and 5. And so 3 pi over 4 is equal to this. 7 pi over 4 is a bit above 5. So when you put that in the calculator, and so that's how you get this answer. And when you graph this, just showing you what you do without a calculator, you can graph this and you'll see that x equals 2.356 is where it's equal to 0. So that's a point of inflection. I hope this helped you guys out. I'm going to stop recording. Thank you guys for watching this video.